Okay, what'd you get? This is by pi over 180. You got what? 25 pi over 18. Yeah, 10 will go into both of those, right? So that's 25, and that would be 18. So 25 pi over 18. Did you guys know your calculator will reduce fractions? I shouldn't make it that easy for you, though. You should do mental math like this in your head. It's good for you. Okay? All right, so everybody knows how to do objective 1. Change radian measure, degree measure, and vice versa, right? Got it? Okay, objective 2. Everybody write objective 2 down. Find the length of an arc. Is someone still writing this down? Okay. Objective 2. Find the length of an arc given the measure of a central angle. Okay, well, what is a central angle? Do you guys remember that from geometry? How many of you had geometry from me? Anybody in here? Wow. I usually only have a couple of students because how many of you guys are juniors or sophomores in here? Yeah, you guys would have taken it in 9th grade. How many of you guys are seniors? Oh, Jenny just moved here, and you took it from Coach P. All right. All right, did you guys learn about central angles? No, you did. You just don't remember. You didn't exactly listen? Okay. Central angle is an angle whose vertex is at the center of a circle. Right here, you guys. Here's the center of a circle, and there's my angle, okay? My vertex is right there. That's called a central angle. Central, think what central means. What does central mean? Center, right? Okay. So that's a central angle. Now, it cuts an arc. Whenever you make a central angle, it cuts an arc out of a circle. And it cuts out this arc right here. Okay? And let's say we want to know how long that is. Like if you were measuring it linearly, you're going to put a tape measure on it and wrap it around the arc. How long is it? Well, we have a formula. It's called S equals R times theta. Everybody say that. One more time. Yeah, S equals R times theta. Okay? Theta. Well, let's talk about S. S stands for arc length. I don't know why they use S for arc length, but they do. Okay? So know that. That means arc length. It probably was made up by some guy in a different language, and arc standard with S in their language. Okay? That's what I'm guessing. Radius. R is radius. And theta. What do you think theta is? The measure of the central angle in radians. Everybody, double and triple and quadruple and 5-tuple, underline radians, not degrees. Okay? You have to have, this formula only works for an angle that's in radians. So if you're given an angle in degrees, what do you have to do? You got to convert it to radians using objective 1, what we just learned, okay? Okay? Everybody got this page down? Okay? No, not yet? Oh, well. Okay. Example, radius is 5. I got to do this for those people at home again. And the angle is 1.3 in radians, and we multiply them, and we get 6.5 inches. Okay. Two seconds. 1, 2. Okay. She really meant what she said. Okay. Find the length of this arc. Everybody find that one. Go. I'll give you a minute. Okay. What are we going to plug in for R, everybody? 12. What are we going to plug in for theta? 8 pi over 5. Now, I could write this as 48 pi over 5. How many of you left your answer like that? Okay. Or we can put it in the calculator. 48 times pi divided by 5. What did you guys get on that? What? 60.319 inches, right? That's the length of the arc. Okay? One more. This one's a little tougher. What? It's not. That was just a test to see if you guys could get this. I'm glad someone caught it. What is 12 times 8? Okay. Man, I was about you guys. I thought you guys were going to catch it before I turned the page. So, okay. Huh? What? Say that again, Dylan? Wait, so it's 96 times pi divided by 560.319? I was thinking 60 was way too big for that. I was like, okay, Bryce. You got to go bathroom? What? Huh? You better go. But you're going to miss this problem right here. Okay. All right. That's everybody listens to this now is going to know, Bryce. All right. Okay. What do you think? This is tougher than their other ones, right? Okay, do it real quick. I'm going to give you a second. Okay, Dylan, what'd you get? Yes. Okay. You just got here, Andrew. Okay. All right. What do you guys think? What was that? How many of you guys got 15.358? Or something very close to that? How many of you guys got 15.358? Yeah, that's a good question. I want to know how many of you guys got 880? Okay. Why'd you get it wrong? What do you have to measure the angle in? What do you mean? The only symbol we use for radians is there's no little circle like a degrees. Okay? All right, so you had to change. You had to times 110 times by pi over 180, didn't you? You end up with 11 pi over 18, and then you're going to go, so the radius is 8, and you're going to times that by the angle in radians. And if you did that, you got 15 point what again? 2 decimal places. 36. Okay? All right, any questions there? Okay? We have one more thing left. We've now done the first 2 objectives. The last objective is to find the area of a sector. Does anybody know what a sector is? This is Dylan. That is right. It's kind of like the shape of a piece of pizza or pie, right? Okay. So right here, you guys find the area of a sector. Well, what is the sector? What is a sector? It's that green shaded area. Okay. What is the formula? All you guys need is a formula, right? A equals 1/2 r squared times theta. And notice theta. What does theta have to be in, everybody? Radians again. Okay, make sure you know that has to be in radians. Okay. This says 5 pi over 6. Okay, if we had this, what's the formula again? Area equals 1/2 r squared times theta, right? So 1/2 of 16 squared times what? 5 pi over 6. Hey, by the way, order of operation. Can I divide 2 into 16, or do I have to square it first? I got to square it first, right? So squared. Does anybody know what that is? Huh? 256. So it's going to be 1/2 times 256 times 5 pi over 6. Well, 2 times 6 is 12. Well, let's see. I know that 2 will go into 256 how many times? $128 times, right? And I don't believe 6 goes into 128, but 2 will go into both of them, right? 2 will go into 6 3 times. 2 will go into 128 how many times? 64 times? And yeah, you can. Because sometimes, you know, it's nice to know the answer in radians. What's 64 times 5, you guys? Someone tell me really quickly. 320? 320 pi over 3. Or what is it in decimal? 300 and what? Point. You know what? Did anybody just type this straight in your calculator like this? Go 0.5 times 16 squared times 5 times pi and then divide by 6 and tell me what you get.
Don't you have to do 1.8 times 5 divided by 6? You have to.
Oh, you can cross cancel first. No, hey, everybody, just so you know, everybody take your calculator right now. 1/2 is 0.5, so everybody go 0.5. And then go times 6 squared times 5 times pi, and then go hit divided by 6. You should get the same answer. Just double check it. There you go. Now, statement right there. Everybody write it down. Now you know how to do all three things right here. You change from radian measure to degree measure and vice versa. You know how to find the length of an arc, and you know how to find the area of a sector. All three things.